Okay, glad to see that you've returned, and hopefully you had some time to think about it. And let's start using these modifiers. So this is going to be one of the longer videos, and essentially we are going to be modeling the entire crate in this lesson. So buckle up and let's work through this together. So let's get rid of the modifier showcase and let's go back to our crate just by making it visible again. So back to our reference model. Right off the bat, I could see that all of my 8 corners are pretty much exactly the same. And they're also pretty much symmetrically placed in our model as well. So when we edit them further, it would be great if any change that is made to one corner automatically flex to the remaining. So luckily enough, we have the mirror modifier to achieve this effect. So let's go ahead and find where our corners are stashed. And we're just going to choose only one corner to work with and make the rest hidden. So I like to choose the one with all the positive dimensions, positive coordinates actually, but realistically it doesn't matter which one you choose. So I'm going to hide the rest. And in fact, I'll just hide the walls and edges one time as well. So if I start to map out some of the symmetries, for instance, if I apply a mirror modifier to this corner, I could see that, well, across the x-axis, I'm going to have a corner that shows up there. Across the y-axis, my corner will be up here. And across the z-axis, my corner is going to be there. So I just know from straight using the mirror modifier, I can get 3 other corners to be exactly where I want. Now just keep in mind that if I were to apply the mirror modifier directly and just set x, y, or z, nothing is going to happen because the origin of the corner is still in the center of the corner. Now I could change the origin to world origin, for instance, but now I'm messing up the origin of the corner. So when I want to go back and edit that one specifically, it's going to be a little bit trickier to do correctly. So another common use is the mirror object in the mirror modifier. And a common object that is used in cases like these can actually be found under empty. So if we go to add empty, we use the plane axis. And the plane axis is going to give us this little object, which looks like my axis. Plus it's already set at world origin because my 3D cursor is set at world origin. So in my outliner, let's just give this a name, call it axis ref, and let's try to use that in tangent with the mirror modifier. So let's give this a mirror modifier like this. Select axis ref, and you can see here already that with my axis ref as my mirror object and the x-axis selected, it's going to mirror across the axis ref in the x direction, and it places it exactly where I want it to be whilst preserving the corner's origin. And the cool thing about mirror objects is that you could even hide the mirror object so that it doesn't mess up with any of the work that you're doing in your scene, but we know to ourselves that where it's located, right here at world origin. Okay, the Y and Z axis also give us the same effect that we expect, which is great. But I want you to take a look at what happens if I enable all the axes at once. So there's the X axis, there's the Y, and then there's the Z. And suddenly, all of the corners are filled in, which is awesome, but why did this happen? Well, the mirror modifier works with everything together one by one. So with the X axis first enabled, we get these 2 meshes placed. If we add them to the y-axis, Blender says, I already see 2 meshes in my scene. So I'm going to mirror both of them in the y-axis, just like this. And similarly for the z-axis, I now have 4 objects in my scene. So I'm going to mirror all of these in the z-axis, and it's going to place them right here. Basically doing all the work for us, very nice and simple. Okay, and the cool thing about this is now if I go and try to edit my corner, first of all, I only get access to one because I don't get to edit my mirrored corners unless I apply the modifier. But specifically, when I edit my corner, I only have to worry about doing my edits on one of them. And if you could see that if I try to make an edit on one of the corners, all of the corners are going to update in real time because they are mirrored versions of the one that I'm working on. This allows me to only focus and name only one corner, which is awesome. Now, if we move on to the edges, back into the reference image, let's start to see if we can do some similar effect here. So, first of all, we could see that for the vertical edges, all of these are going to be the same. So we could definitely use the mirror modifier for all of these vertical edges. Now for the horizontal edges, we have different designs going on. And at this point, we could just choose what we'd like to do. So for the bottom edges, we see that we have this design going on, and we have this one going on. Between these two, I'm more of a fan of the one that looks a little bit plain. So this one over here, just because the bottom corners are not, doesn't have to be as interesting. And we already have the top edges that we discussed before to be the interesting sort of horizontal edges. At the end of the day, it's all preference choice, and I like the plain one a little bit more. So that's the one that I'm going to keep. And I think I'm going to make all four of the bottom edges, horizontal edges, the same plain design as well. Now, the top four edges have a completely different design. So when we use the mirror modifier and start to edit, we could have two separate meshes. One of them that deals with the top edges, the other one deals with the bottom. Okay, and the only problem here is that we could see that there is some use of mirror modifying going on, but the complication comes to the fact that we don't have a way to achieve rotational symmetry yet. So the cubes didn't really give us this problem because all of the dimensions are the same. But this one, you could see that even for the top edge, the long side is this way, but if we were to mirror it and put it over here, we also have to rotate it. Now, the only thing that we've discussed so far that mentioned rotation was the mirror object tool in the mirror modifier, because the mirror object, you could also set the rotation there. And you know what? Speak of the devil, using the mirror object and rotating it is going to be the solution to achieve what we want. So, I can explain to you how you could use an object's rotation to get the desired result, but if you think it's easier to work with only one side, like this, and modify it to get the result that you're looking for, and then you just duplicate it to the other places like how we did at the beginning to get the edges in place in the first place, you're allowed to go down that route as well. So we're either going to use a modifier approach or a duplication of the mesh approach. And at the end of the showcase, you automatically get to decide which one you prefer. Okay, so before we do the edges, let's just finish up our work with the corner. So this corner already has everything, so I could select the hidden ones. We don't need them anymore. And I'm just going to press delete on my keyboard. And now I only have one corner to work with. So let's move on to edges. I'll hide corners, put my focus onto edges. Let's go with the bottom edges first, because I want to show this rotational symmetry example. So let's remove all the vertical edges, and for the horizontal edges that you don't want, we could just select them and press H on our keyboard to hide them. And that's just going to hide them in our outliner as well. So I've just chosen this one as a starting point. And just to refresh, my goal is to keep this object, but get mirrored edges to look like this. So what we'll do is let's add that mirror modifier and set the axis ref like this. Okay, and because I want to use this axis ref and I want to be experimenting with the rotation, I don't want to mess up the rotation that's happening to the corners, because axis ref also corresponds to the corners. And just to show you what that might look like, if I make the axis ref visible again and I try to change the rotation like this, you can see that some of the corners also start to move in place. I don't want to mess up that work right now. So the best thing I could do is I will duplicate this like that. And I'm going to name the one for the corners. Let's just put it underscore corners right now. And I'm going to rename the new one underscore edges. And while we're here, let's just make a new outliner. Not outliner, collection. Let's call that axis ref. And we're going to just keep both of them in here. Just like that. All right. Let's hide our corners again, and we're back into the edges work. So we already know that by setting the axis ref edges as a mirror object, and if we mirror this across the y-axis like this, this will give us the result that we want. But how do we get the ones on the left and the right sides? So the first thing you want to do is that remember that a mirror across the y-axis, which is what we're doing here, is the same thing as a reflection over the xz plane. So the xz plane is the view that you get over here, and this entire plane over here, this is your xz plane, and it's going across that. So just to visualize that a little bit better, to make this showcase a little bit easier, what I'm going to do is I'm going to create a very dummy object. I'm going to use a cube, and I'm just going to change some of the dimensions. So don't worry too much about this. I'm using this as a demonstration to show you that this cube essentially is going to act like the xz plane. So we can see that when you mirror across this plane, it puts into place. Now I want this cube, this plane to move while I also move my axis ref. Now, a cool way of doing that, which you don't have to worry too much about right now, is that if you select an object and there's this little constraints tab, I can add a constraint called copy rotation and set that object to the object I want to copy the rotation from, which in this case is axis ref edges. All this allows me to do is that when the axis ref edges rotates, I could show that this plane rotates as well. This is going to be a little bit easier to demonstrate what's going on. Okay, and the reason I use the cube instead of a plane is because you get this top thickness. So you could actually see the cube rotating in real time as well. Okay, let's go back to this object over here. In the mirror modifiers panel, let's choose the right axis ref. I had the corner set accidentally. Now, take a look at what happens if I start to rotate this axis ref. When you rotate it, you can see that the mirrored object is also rotating as well. And if I keep increasing this and increasing this, when I hit this 45-degree mark, which is right over here, this actually puts the edge in the exact place that I want. Now, why did this happen? Well, this demonstration showcases is that when you have a mirror object and you rotate that mirror object, that plane that revolves around the mirroring also gets rotated as well. And because that mirror plane also gets rotated, the mirrored result shows up in a different location. And if you could see that if I try to change my view such that to make this mirror a little bit more vertical, something like this, you could see that this object is exactly mirrored across this plane right in the middle. This is how we were able to get that rotational symmetry effect that we've been looking about so far, which is pretty cool. So the natural question is, how do I get these last two edges into place? Well, take a look at this. To get these two edges into place, I already have these two edges already set. So to get the mirrored edges, I would need to rotate or mirror across this plane. Now, what does this plane refer to? Well, this plane is actually the mirrored YZ plane. Not the mirrored YZ plane. It is the 45-degree rotated YZ plane, and a reflection across the YZ plane also just means is the same thing as a rotation across the x-axis. And in turn, I get the four edges that I want right into place. Now again, if the showcase was a little bit complicated, again, you're more than welcome to just put one of these into place and duplicate it and rotate it to get the other four into place, just like how we did it in an earlier lesson. Now, I'm not going to go down that route since all this work is already done, but you have the option of how you could progress. And don't worry too much about if you have more objects than me in your scene. At the end, we're going to be joining everything. So we're going to have the same end result, just different ways of getting there. Okay, so with that demonstration aside, I don't need this plane anymore, and I have the set and so on. Okay, so Now with that out of the way, so we want this to be our bottom edges. So let's rename this to bottom edges like this. And what I'm going to do is let's hide this bottom edges, Alt H to unhide everything that we've hidden so far, which is this. And my goal here is to just delete the ones that we don't want anymore. So these are the 3 edges that correspond to the bottom edges that we've replaced with the mirror modifier. So I'll go ahead and just press delete. Those are out of my way. Okay, and the case for the top edges are the exact same. So we're going to do pretty much the same thing here. So find 3 that we don't want. We're going to delete it. For the top edge, let's give it that mirror modifier. Choose axis ref edges for a mirrored object like this, and enable X and Y. And let's just rename this in the outliner to top edges. Great, so we got the top and bottom edges into place. Now, for the case with the vertical edges, which are these 4, this one's a little bit easier because there's no rotation that needs to happen. We just need a straight mirror across the y-axis and also across the x-axis to get these 4 pillars into place. So that means if we want to use the mirror object approach, we actually want to choose the one without rotation, which is axis ref corners. Now the problem with using axis ref corners to set as my mirror object is because intuitively the names are a little bit disconnected, right? I'm working with edges, but I have an object that's named corners. So to keep it consistent and to generalize our 2 axis refs to be applied to many different models or use cases that we might need, instead of renaming this underscore corners and edges, let's change the name into what's special about them, which in this case is their rotational transformation. So what this means is that for my corners, instead of underscore corners, I'm just going to change it to rot 0. So it means rotation 0. In other words, no rotation has been applied to it. And my edges, I'm going to change this to underscore rot 45 to indicate that I had a 45-degree rotation. And in this case, we're just talking about the z-axis. So if you wanted to specify and put like a z somewhere in the name, that's completely up to you. But I know what I mean when I put rot 0 and rot 45. Anyways, with that in mind, let's choose one of these vertical edges, delete the rest, and with the mirror modifier selected, we're going to set the mirror object to that rot 0, enable an X and Y, and just like that, all my vertical edges are into place. And let's just rename this to vertical edges. There we go. Okay, so my work with all of my edges are done, and you can see that all this lovely work has been into place. So let's move on to the walls now. Now the case of the walls, at first glance, it's very similar to how the top and bottom edges work. You know, we have 4 similarly designs, and they're all rotated like this. But if we turn back to our reference model, we actually see that we have 2 different designs going here. This wall has a vent-like design, and this one is a little bit more plain. So instead of doing the rotational symmetry effect to mirror it, we already know that this wall we can make these 2 opposite walls the same. So let's put a tick mark there to show that these 2 we want as the same. And this wall we want to be the same. So we actually have 2 different wall designs going on. So instead of having rotational symmetry for mirroring, we could just mirror it across the opposite axis to get them in place. So we're going to be using the rot 0 axis ref for a case like this. Okay. So what we'll do is erase that, and let's just start putting these in place. So this one, I'm going to call this, I want this to be my vented walls. So walls, vent. Like this. This one is going to be the mirrored one, so I'll delete that. And we will apply our mirror modifier, axis ref 0, rotation across the y-axis. So that gets this put into place. And for the other wall, let's rename this to walls plane to be the plane version, delete the other one, and we're going to put it back using the mirror modifier mirrored in the x-axis. All right. So just like that, let's bring everything back just to take a look at what we've done. We've improved our outliner so much, and we set it up into something more manageable, and we've only really used the mirror modifier so far. So the mirror modifier is a great way of cleaning up your scene and making your workspace a lot more scalable. Now with this setup, we can start to focus on individual elements. So let's go back to our reference image and start to think about what we're going to do with the corners. Now, from the reference image, if we take a look at one of these corners, I could see that the corners look to be beveled. So these edges here are a little bit rounded, which is similar to the bevel effect. So the bevel modifier automatically pops into my head. In the inside of the shape, we see that we have some of these circular shapes. So maybe these are insets of circular shapes. But we can, of course, stick to whatever shape that we feel comfortable with. You know, we could use a square shape or really anything. But we know that some shape should be insetted to get this design that we're going for. And yeah, that's pretty much the main two things of the corner. So let's start to do that. So let's go back to my corners like this. I'll change this name to corner since we have multiple. And I'm going to start by applying this bevel modifier since we want the bevel modifier effect for the rounded edges. So if I apply this bevel modifier, the first thing that you could see is that in my modifiers panel right here, objects can have more than one modifier applied, and it actually gets placed into a stack. So a stack like this with multiple applied. So this stack acts as a hierarchy on the order of how modifiers are generated. So the top one gets applied first, the next one down gets applied second, and so on if you have more. So in this case, the mirror modifier is applied before the bevel modifier, but as you can imagine, this is going to give us the same effect as if we were to just bevel the corner first and then just mirror everything. So the order in this case actually doesn't matter. And also right here in the end, these 8 dots, you can hold and drag them to change the order of modifiers in your stack. Okay, so let's open up that bevel modifier like this, and we could see that this is how it currently looks like. So I personally think that right now having one segment looks pretty good, but the offset, the rounded edges are a little bit too skinny for me. So I'm going to just bump this up a little bit, somewhere around, let's see what 0.2 looks like. Yep, 0.2 even looks good. Maybe even just playing around with the segments. This also looks great. And yeah, I'm pretty happy with this. So the bevel modifier is one of those tools where I like to use very nice numbers in this case, going up by 0.1s for the amount. And you just sort of play around with the segments until you get a feel for what you are going for. Now, of course, bumping up the segments is going to give a lot more rounded result like this, but this in turn, you're creating a ton of geometry. So if you scroll in, look at all this geometry that we created. And you could even see it here in my statistics, you are in the hundreds of thousands of triangles, which is a lot. So even though it looks great, don't go crazy about using this modifier. We still want it to be something very manageable. And these are the settings that I will stick with. So just to make sure that there's no funny business going around here, I also noticed that we didn't apply the scale of our corners. So let's do that really quickly. If we go to Object, Apply, Set the Scale, so that's going to change the scale from 0.5 to 1, and check it out. This actually changed the result. Now, it's a good thing we caught that at this point in time because who knows what could have happened down the line. It could have been proved to be a bigger issue. So we kind of got to get back to the design we initially had. So we doubled our scale from 0.5 to 1. So maybe if we just half the amount back to that 0.1, yeah, this gives me back the original result I was looking for, which is great. Yeah, so again, just play around with the bevel modifier, get a good feel for it, and try not to create much more geometry than you need. Also, don't forget to save your file if you've not been doing so already, We've done a lot of work already. It would be a shame if we lose all of this. Okay, with the bevel modifier dealt with, I am going to tab into edit mode to work on the inset faces, and we could actually see here that we're still working with our old mesh. We don't have access to the smaller geometry yet because we didn't apply the bevel modifier. Now, at this point in time, if you are worried about applying your modifier and doing something you might regret, you could take this opportunity to create a duplicate for the corner mesh, rename it something like a backup, and in case you want to fiddle with the beveling later and redo this process. But at this point in time, I'm pretty happy with the image of what my corners look like. So I'm just going to go ahead and apply this bevel modifier, which is something you can only do in object mode. Okay, so that's applied. And you may have noticed that we got this little warning message on the bottom stating something that because this modifier was not the first thing in the stack, the results may not be as expected. We know to ourselves that the order of the mirror and bevel modifier in our modifiers tab doesn't change the effect. So it doesn't matter if I applied it there, but if you are, anxious about something going wrong, I could Control Z to undo this process, move it back first in the stack, and hit apply. And the same thing happens with no message on the bottom, just to make, just to make it feel better. Okay, so if we tab back into edit mode, I can now work directly on these small faces. So now we got to move on to the inset faces. Well, we know to ourselves that a cube has 6 sides, but specifically in our model, out of the 6 sides, only 3 of them are going to be visible, and the rest of them are kind of covered by the adjacent edges. So when we try to inset these faces, it doesn't make sense if we do it to every single side if only half of them are visible. Okay? Now, to work with these faces, reminding ourselves Blender is reporting a side length of 0.8, which makes sense to us because we applied a 0.1 meter cut or offset when we use the bevel modifier. So that's squished off 0.1 meters in both sides, and the original dimension was 1. So 1 minus 0.1 minus 0.1, this gives us the 0.8 edge length that we expect. So no funny business just yet. Okay, so with that in mind, I could select all 3 of these faces, I'm pressing I on my keyboard to inset, and this is going to inset a smaller face. So I'm just going to click somewhere to confirm I want to inset, and I will tweak it here in this pop-up menu. Let's choose 0.1. And the reason I chose 0.1 is because my bevel offset was 0.1. So I'm just using a similar number just to give a little bit of an effect of consistency, just so everything feels equal in some way. All right, so now with these square faces in place for this new geometry, this is the point in time where I could start to decide what shape I want them to be. Now let's say you want to get something closer to a circle. So there's different options that you could use to achieve this effect. One of the options is, well, you can go to your handy old knife tool and carve out a circle. But as we discussed before, the knife tool can often be imprecise and it might just create a lot of funny business going on. Circles are very nice rounded objects, so unless you're very careful and meticulous about how you're using the knife tool, you're probably going to get a funny looking shape. Another method that you could consider is using the loop cuts. So if we add loop cuts to this object, somewhere around this, I could add one to this face as well, but let me just show you what the result will look like for this face. So loop cuts will cut this into half, giving me all of these vertices, which I have here. And at this point, I can, move these vertices a little bit like this. Obviously, I'm doing this freehand, but you can calculate this if you want. You can get an effect like this, which even though it's an octagon, it does give you a more circular shape than obviously a square. So you could go down that method. Also, a cool tip here is that when you're moving these vertices, we already know that pressing G moves them freely, but if you press G again, it will actually lock your movement to neighboring edges like this. So that's a cool little trick you want to do to make things a little bit more consistent. Okay, so that's another method you could do. Now the drawback of something like this is that you are now splitting up these edges over here. these edges are not going to be changed. You know, it would be nicer if this was just one giant rectangle. So you're actually creating a little bit more geometry than you need to, which it's not much, but in terms of optimization, you may not want it. So that's the second method. You can go down that route. Let me just undo to get back to where we were. Minus loop cuts like this. And the third method is that you could do a subdivision tactic. So what this means is that with my edge selection enabled, I can select this edge, right click and press subdivide. And subdividing works very similarly to the loop cut tool in the way that it allows you to split up this edge into this number of equal number of cuts. So if I have two cuts here, one cut there, one cut here, it splits it up into three equal pieces. Right? And I'm going to bump this up to 3, and I'll show you why in a second. Now, the reason I have to do these edges one by one is because if I try to select all of these edges and do everything at once, this face also gets highlighted one time. So if I try to subdivide it and bump up the number of cuts, it's also going to subdivide this face, which is not something I want to do right now. If you do it, we're going to end up deleting them after anyways. So I will stick with subdividing, bringing the cuts number to 3. And we'll do this for all of these edges around here. Just like that. And back in vertex select mode, I have a bunch of these new vertices that I could work with. So with all these new vertices in place, the first thing I want to do is I want to delete this face. Let's delete this face by pressing delete face. So you can see that the face is gone. And now, with these vertices around, in each of these corners, we have find the 3 neighboring vertices in the corner. We're going to choose these 2 for every corner, and then actually, we have to select all 3. Then press F on our keyboard, and it's going to create a face with those 3 vertices. And let's do this for each corner. That gives us this result. Now, the reason I wanted to delete that middle face first is because if you kept it there and then created these faces afterwards, it's actually going to create that face on top of the giant square face. And that's going to give you 1 more geometry than you needed, and 2, it's going to create this glitchy effect, which you could see is happening in these back faces over here. Now, the glitchy effect is okay if it's inside of a shape because that's something visible to us on the outside, but that's just something to be wary of. Now, with this shape in mind, I can now go ahead and if I could select all of these faces here, like these, so I have 12 faces selected. I'm going to press F on my keyboard just to fill it in. So if I was going with a little bit more of a circular face, this is what I would go end up with. Now, yes, it is an octagon, but an octagon is a little bit more circular than a square. Obviously, if you wanted a really nice round shape, these number of vertices that you have will have to be subdivided a lot more. That's going to give you a lot more geometry and a little bit of very intricate moving around that you want to do. Now, the calculations behind where to move exactly each of the vertices to get them in a place to make the space look a little bit more circular, it's very intricate. And unless you're very skilled with that, you may want to opt for a more simpler design. But yes, so this face I created here is an octagon. Now, to us, it looks like an octagon because it has 8 sides. But to Blender, it's actually a 12-sided shape because I actually have all of these extra vertices here in the middle. Now, this is an n-gon because it has 12 vertices. So even though that this is an n-gon, and we already talked about the fact why n-gons might be bad, in cases like this, it is actually okay, since we're not going to be deforming the corners in any weird way where the shading in the end might give us funny business. And in fact, I also noticed that these middle vertices don't really have much more of a purpose than existing, so I can dissolve these vertices, which will keep the original edge but get rid of any unused vertices. And now we have an octagon shape. Okay, so this is how you can achieve something if you're looking for a different kind of shape. But me personally, if I compare this to the square face, I think I like the square face a little bit more. So that's the one I want to be using. Okay, so let's try to undo this, and I don't know if I have enough undos to get back to where I started. Yeah, you can see here that I press undo the max amount of times, and I sort of got led up to this point. So that is, again, a little bit of a drawback from using destructive edits, is because if you go so far into your project and you want to change your mind a little bit later and you try to undo, it may not take you back to exactly where you want to be, which is why the backup option was a good place. Otherwise, you're just going to have to manually get back to the result you initially had. Now, in this case, it shouldn't be that difficult. I could show you how to get it back from here. So these four edges, I obviously don't want it. So I could delete these. Then these extra vertices, I don't want to, I don't need them anymore. So we will dissolve these, pressing delete dissolve vertices. And now I could just select my little square here, press F to fill the face back in. And that just gave me the result I had before. So even though that you had to do a little bit of extra work, I think it's a little bit good that we found this error because you had a little bit of practice on how you can manually change your work if you ever run into a situation similar. Okay, so that was a little bit of a quite a long tangent, but it's okay. I saw the importance in it. But now we can go back to selecting these square faces. And what I want to do is I want to move them inwards. So I'm going to go to my extrude individuals and individually extrude them inwards. So I'll pull this inwards like this and select it. And in my little pop-up menu, let's just continue and use 0.1 offset just to keep up with the consistency. And this is the result that I have here. Now, of course, if in your version, if you think that this offset is a little bit too small or too big and you want to change it, even though extrusion is a destructive edit, one cool thing that you could do is if you select one of these faces, you could use these axes to move it inwards or outwards. And then just select exactly the amount you need. So that's one way that you can get out of this problem. All right, so let's go back into object mode. So my corners actually seem to be done in this case. And if you want to take the step a little bit further, a cool thing is that you could actually right click and they have in object mode, you have a couple of smooth options. So you could use shade smooth and this will shade out all the edges to make everything a little bit more rounded. Or you can shade smooth by angle, which is basically Blender saying that for any angles that are 30 degrees or less, it's going to make them smooth. But the sharper ones, like these 90-degree angles in the middle, it's going to keep them and not smooth them at all. And honestly, between those two options, I'm liking the shade smooth by angle a lot more. So this leaves us to this. Now we did a lot of talks at the corners, I know, but I think with all that practice that we've done, the edges might be a little bit faster to go about. So let's move on to the vertical edges next. So back into my reference model, we have, again, we have some beveling action that's going on here, right there in the middle. And we also have this little vent design on top. So we got to make space for that. And we also have some screws in the center here, which is something I'm thinking that we could just create as a separate mesh later. So I don't need to really change the geometry for these screws. And lastly, there's something happening on the bottom, but I honestly don't know what it is. So we are just going to ignore it and imagine that it wasn't there. So the main thing is make space for the vents on top, bevel the edges. So let's do that. Let's go to my vertical edges like this. I'm going to bevel modifier that. Apply the scale really quickly. So apply scale. And I'm going to use the same settings, which was this. Okay, so back in edit mode, I need to make space for the design on top. Now, honestly, at this point in time, I am not exactly sure the correct steps to achieve this result. So what I'm going to do here is I will actually duplicate this vertical edges mesh and try my little shenanigans on this one. So I'm just going to create this duplicate underscore test, hide the original one, and let's just test this one out. So I want to do my work in edit mode. So let's apply this bevel, go into edit mode so we could work on this geometry. And what I really want is to put my vent somewhere right here. Okay, so just kind of, oops. So just kind of mapping out how I might achieve this effect. So what I'm thinking is that we can create a loop cut here like this, bring this up to around there, like this. What this will do is that it will split this face into these two separate sections. At this point in time, I can create like an inset here, extrude it inwards, and that little space I've created will be for more of my vents. So actually, I think I overcomplicated the problem a little bit. Something like this is kind of the effect I'm going for, and we'll do the same thing for this face. So I have a clear path on how I want to get there. So you can keep this here just to reference what you did. I kind of remember the steps I took back since it wasn't a lot. So we will delete this and do our effects on the good copy. So we are going to keep this bevel modifier since this is good. Then in edit mode, I want to make sure everything is precise. I definitely do want that loop cut here, but with the vent design that I have on top, like this, it would be nice if that is a square shape. So I need to figure out how I can move this edge up to somewhere here, such that I create that square face on top. Okay, so how can we figure that out? Well, with my statistics enabled, I could see that this top side length over here is 0.5 meters. So that means I would want 0.5 meters over here. Now, another thing about this is that if I look at this specific edge in edge select mode, my Z coordinate is 1.4 meters. So if I want this height to be 0.5, this edge should go up to be Z, well, 1.4 minus 0.5. That's going to give me 0.9 meters. So I want this edge to be at that 0.9 meter mark. Okay, so with that in mind, like this, I can shift select or alt select this edge. Oops, I'm not in edge select mode. Alt select this edge. That will select the entire edge loop. And I am going to bring this up to 0.9, just like this. And now I have square faces right here. That's good. So with these two square faces selected, I to inset, click to confirm it. I've been using 0.1 as an offset a lot, so let's choose that. Actually, in this specific case, that 0.1 meter offset is a little bit too small. So let's try halving it to that 0.05, like this. That one looks a little bit better, which is good. And now I can go to my extrude individuals right here and bring that inside. Now the offset here, let's try that 0.05 again. That one's a little bit too skinny, so maybe I'll go back to the 0.1. There we go. Now we got a little bit of room for those vents. And I like this one a lot. So all in all, these are looking pretty good. Back in object mode, this is what I have. You see all the vertical edges have the same thing. And as that finishing touch, we'll shade smooth by angle this one as well. And this is the look that we got going on. All right. Now the bottom edges back in the reference model, they don't have much going on except the beveling action. So let's just knock that out real quick. We'll select the bottom edges. Let's add that bevel modifier to the top. Apply scale. Like that. Change the settings to be the same. And then we're going to shade smooth by angle. And that's going to leave that to be exactly where we want. Now notice for these instances, for the bottom edges, I don't have to apply the bevel modifier because I'm not going into edit mode to change anything about it. So that's a good habit to have. If you don't see yourself having to apply any of these modifiers right away, it's a good thing to keep them there. So if when you do change your mind, you have that option to do it right away. So nothing to change there. Next, I'm going to move to the walls. So the vented wall in my reference design, again, it has this giant space cut out for the vent. Then it has these screws, but similar to the edge approach, we can create those screws with a separate mesh. So nothing to worry too much about there. And we have some lines going on here, but those lines look like it's probably from a wood texture. So when we paint and design our walls in the end, those lines could possibly come from that. So nothing really to change with the geometry. So it's just really some beveling around the outside and the space in the middle. And of course for the other wall, same thing. We'll keep this one plain, and all of these screws and lines might come from texturing. So that's good. So I'm going to go to my walls, and I'm going to start with my walls vent, which are these ones. So the first thing I want to do is let's apply the bevel modifier again. Actually, apply the scale like this. Change the settings to be consistent with everything, which is that. And I want to actually create that inset for the wall face. So this is a case where I'm going to apply this bevel modifier, tab into edit mode, and I have this geometry to work with now. And let's create that inset. So I to inset, click it somewhere here. Let's stick with that 0.1 again. Well, 0.1 in this case looks a little bit too narrow, so I might even bump this up to 0.2, just like this, which looks pretty good to me. But now what I want to do is I want it to look like a more vertical rectangle. So these edges are a little bit too far out. I kind of want to push them inwards a little bit so that they are somewhere here. So I get this nice tall rectangle shape in the middle. Okay, so one way that I could do that is with this face selected, I can press S on my keyboard to scale and then the X button so I can only move it in this way. Now, before I do anything, I want to take note of this edge length, which is 3.45. So I'm trying to keep around very consistent results when I move these edges. So let's bring it somewhere around here. I think around here looks a little good. And you could see that my new edge length on the bottom is 1.46. That's very, very close to a 2-meter change. So actually, to make that a little bit more consistent, I'm going to go back to that scale X and change it to 1.45. And the reason I did that is so I could use nicer numbers. So there's a 1 meter brought in this way, 1 meter brought in this way. Now, to the naked eye, honestly, doesn't matter. You could change the width of this rectangle to be whatever you want and just eyeball it, really. But I always like to use nice numbers when I'm working with everything, because the edge lengths, as a result from all of this, are going to be nice numbers for me to work with. And this is the result that we have, which is great. Now, at this point in time, we can press E to extrude on my keyboard, and we're going to push it in like this. And let's actually try that 0.2 extrusion to be consistent with the offset. And the walls are a little bit bigger, so I think a bigger thickness or offset for the extrusion is a little bit better here. So I like this result. And this is what it looks like in object mode, pretty good. And shade smooth my angle to get the edges nice and rounded. There we go. Now for the walls plane version, this one is pretty easy. We could just apply the scale, add the bevel modifier like this, Change the settings, they'll be the same. Shade smooth by angle. No more work needs to be done there. And there we go. Now, to finish off, we have this top edge to worry about. Now, in an earlier video, as discussed, the design that we want to go for is to split that top edge into these three separate meshes, where the middle one is a little bit longer to extend out to that connector piece in the middle. So, let's think about that. So, if we brainstorm a little bit, if we split this into three equal pieces, well, the first thing you want to notice is what was the original dimension or the length of this edge. So this dimension that's being relayed to us in the transforms panel comes from the entire mirror object. So if we want to remember what one of these objects looks like, we could always disable the modifier in real time. And we could see here that X dimension, this long length is 4 meters. So there we go. So we know that this long length is 4 meters. So if we split this up into 3 parts, each of these are going to have a length 4/3, like this. Now 4/3 in our calculators gives us that 1.33 dot dot dot. It's just threes forever. I don't like working with very long decimal places, so what I'm thinking is I'm going to make these outer edges, so this one and this one, I want these to be a little bit bigger. And the reason I want them to be a little bit bigger is that when I start to have this middle connector piece from all the sides, this gap that's being created, I want it to be big enough to store, like a bottle or something, which is something we had a little bit of discussion about. If this middle connector piece was longer, let's say back here, you would need a very small bottle to store in that small space on top. So I think actually narrowing the middle piece to be a shorter length is actually a good idea in this case. So let's do that. So just to refresh ourselves, because we are working with approximately around that 4.3 area, which is 1.33, I'm thinking that we can bump up these lengths over here to 1.5 meters. And therefore the middle piece could be shrunken down to 1 meter. And therefore, if we add up all these numbers, 1.5 plus 1 plus 1.5, that's going to give us the original 4 meters that we had. So this is the direction I am thinking about going towards. So let's do that. So how am I going to do this with this setup already? I am going to take this dimension and I'm going to start, I already know I want to change this to 1 meter. So I'm working with the middle piece right now. And I don't have to change any of the modifiers yet because this is going to be rotated anyways. Where is it? The top edges, like this. Okay. So that's good. We have this piece in place. How are we going to get the other two pieces in place? Well, if I take a look at this side edge, we know that this is 1.5 meters long, which is what we were tracing for. And the origin is going to be somewhere around here. Now, this origin has an x-axis. Well, it's located at x is equal to 0. So what x-coordinate is this one going to be? Well, this distance between these two origins is just this half distance plus this half distance. And this is easy to figure out because we already know that this dimension is 1 meter. So this half distance is 0.5. And because we want this to be 1.5 meters, the half distance is 0.75. So if you add up 0.75 plus 0.5, that's going to give us 1.25 meters as an offset from the middle piece's origin. Now, of course, the sign is going to be different because we can either be going to the positive or negative x direction. So in this case, the negative x direction is on the left. So To get this piece into place, we'll have to go negative 1.25 in the negative x direction and 1.25 in the positive x direction to get this piece in place. So let's do that. So the easiest way for me to do that here is to select this, duplicate it with Shift D, right click to put it back into place, and I'm going to change the location to negative 1.25. There we go. Negative 1.25, bump up the dimensions to 1.5, like that. And same thing with the other one. Shift D, right click, location positive 1.25, bump up the dimensions, just like that. And these are this is the middle piece. These are the two duplicates that I created. Now, just to recall, duplicating also duplicates any modifiers with it. We don't need any modifiers because what we want to do here is we want to take these two pieces and join them to this middle piece and have this middle piece's modifiers dictate everything. So the easiest way to understand about how to do this is, well, if we don't want modifiers for this piece, let's remove it. We don't want modifiers for this piece, let's remove it. Let's go ahead and select these right now and apply the scale like this. And now I want to join them. So the way to join pieces is that in your outliner, select all the pieces except the last one. Then select the last one with Control Select. By doing it this way, the last selected object will be highlighted this light blue, so it has priority. And because it has priority, when we go to Object, Join, or Control J, everything gets merged together and joined into that one masterpiece. And the information about the origin is the one with most priority, which is that middle piece. Now, don't worry about in object mode if it still looks like a giant edge. In edit mode, we could see that this was clearly split up into 3 separate meshes. Now, the cool thing about joining meshes is that we can still access each of the meshes that we've joined before. So in edit mode, we see that all of the pieces are here. If you hover over one of these pieces and press L on your keyboard, Blender performs a linked select, which will select the original meshes that you've previously joined. And you can see here that if I just keep hovering and pressing L, I am link selecting each of these meshes one by one, which is pretty cool. The also cool thing about joining meshes is that because there are technically 3 meshes as a result from here, when you apply a modifier, it will actually happen to each of these meshes individually. So take a look at this. If I apply a bevel modifier, it's applying these settings to each of the specific meshes that I had, which is also pretty cool. So we already applied the scale to this. Let's change the settings to be what we want, like this. And we have that down pretty well. So let's keep this like this for now. So back in edit mode, we know that this middle piece will want to be a little bit longer. So I actually don't need to change the to apply the bevel modifier to move this face, because I actually want to move the entire face, not just the little square one in the middle. So I could actually drag this up a little bit like this, and that bevel modifier will update itself to round out to each of these corners, and nothing's going to look stretched. So yeah, this is sort of the result that we're looking for. And if I make the mirror modifier real time, this is kind of the effect that we have so far. Now, of course, we need this middle connector piece. So we should start drafting what that's going to look like. So let's go back in object mode and add a middle connector piece. So let's add a cube, and let's do a little bit of math to figure out what dimensions we want this cube to be. So in edge select mode, not in edge select, in edit mode, we know that the dimensions of this face, this is 1 meter by 0.7 meter. So this little face in the middle, we already know how to calculate this. because the offset in our bevel modifier is 0.1. So that means if I shrink off 0.1 meters in any of these sides, that's actually going to make this top edge 0.8 and this one 0.5 meters. So the middle connector piece, I want it to be 0.5 meters tall, 0.8 meters wide, and because I have these side pieces like this, 0.8 meters here, which we discussed before, but because all of these are mirrored identical objects, I want it to be 0.8 meters long as well. So that's going to give us this little shape from the top to work with. Okay, let me show you what that's going to look like. So I'm going to select Edges Collection because I want to add my connector piece in this collection. We're going to add a, oops, very fiddly, add a cube like this, and the height of it was 0.5, 0.8, 0.8 for X and Y. So that has the right size, and just to remind ourselves, these pieces are at Z is equal to 2 meters. So let's bring you up to Z is equal to 2 meters. There we go. We have this so far. Okay. Now, let's start to make this cube a little bit fancier, because right now it's very plain. So, what we want to do is, let's apply the scale on this cube, like this. We're going to add that bevel modifier, like this. Actually, no, let's not apply the bevel modifier yet. I think the easiest thing to do would be to create that little plus sign. So the plus sign I'm referring to is extend each of these out a little bit like this, and then have these pieces connect directly to each of these faces. So let's achieve that effect first. And the way that we are going to do that is we are going to select all the lateral faces of this cube, which are these 4 faces. Go to extrude individual, and we are going to bring this out like this for a plus shape. And I'm thinking about I'm thinking the 0.2 meters offset looks pretty good. All right, so 0.2 meter offset like this. And now the only thing left to do is to make sure that this face connects with this face. Now, one cool thing that you could do is that if you select, let's disable this to make it easier to understand for what one edge is going to look like. I could select the piece, 2 meshes at the same time, and tab into edit mode. And you could actually use all your edit tools on both of these meshes together. I usually find this helpful when I want to access specific information about transforms and locations to make things a little bit easier to work with. So, this face over here, this is at y is equal to 0.6. So that means I want to take this face and I want to bring it up to that y is equal to 0.6. Oh, wait, no. Negative 0.6. My bad. Negative 0.6. Oh. Oh, let me back up a second. I've been doing these on their local. This 0.6 is the global space. So let's go back to this. This face. And in their global, this should be negative 0.6. Again, global and local spaces give you 2 different coordinates. One works with coordinates in the entire scene, and local refers to just specifically revolving that one mesh that you're doing. So yes, it's very helpful to work with stuff in global space to get this result. Either way, we have it exactly where we want. So that's looking good. So everything is into place. I could re-enable my mirror modifier. We know that the rest are going to be put into place. And we'll spice up this connector piece by adding that bevel modifier, same settings. And that's looking pretty good. The only thing left to do here is let's shade smooth my angle for these, shade smooth my angle for the connector piece, and then rename that connector piece. We're going to call it top edge connector. There we go. And just like that, we've transformed our initial cube into something like this. Okay. And I could actually see here that I've completely just missed the bottom piece. So let's figure that out really quickly. Go back into, not edit mode. How are we going to figure this out? Let's edit mode like this. So what we're trying to do here is we want, oh yes, these edges are 4 meters long, so we definitely need to create a 4x4 piece on the bottom for it, and we want to make sure that the Z origin is in the same -2. So let's do that really quickly. Let's add bottom here, and inside bottom we're going to add that cube, bring it down to, what was it again? Was it -2? So we're going to bring it down to -2. We want this to be 4 meters in the X, 4 meters in the Y, and the height of it, well, I'm going to keep the height to be similar to these edges. And these edges were 0.7 in height. So there we go. We have that middle shape down, which is awesome. And now that's all left is the offset. So the offset, we're going to want to apply scale first to make sure there's no funny business. And what's the difference between these offsets? So if I press and select both of these edges, I can go into edit mode and take a look at where the faces are located. This face in global space is at y -2.15. This one is at y is equal to -2. So there's only a 0.15 offset distance between this face and the edges. So now we know how to achieve the effect. We select all these lateral faces like this, extrude individual, bring it out, and it's going to be 0.15. There we go. That's going to put this into place. And last but not least, we're going to bevel this. Same settings. We don't need to apply yet. Shade smooth by angle. So there we go. We've knocked out the bottom piece. Now this is starting to look more like a crate, which is awesome. So we've got the general shape pretty much covered out. So just take a second here to congratulate yourself to make it to this point. The only thing that's left to do is we got to create the vents and some screws for this. So let's knock that out really quickly. So the vents, they are quite thin. So what we could do is we can start with a plane and then use the solidify modifier to adjust that desired thickness. Now, tiles are usually layered on top of each other, so we can use the array modifier in the z-axis to achieve that effect. So I'm actually going to start with the vents for the wall. So back in edit mode, let's select this, back in edit mode. This is the face. You can actually see that we're greeted here with some blue edges. Now don't worry too much about this. I'm going to explain more about these blue edges in chapter 4. But if you're curious, these blue edges were created specifically using the shade smooth by angle object mode. So they didn't just pop out of nowhere. Okay. So we want the dimensions for the space of where the vent is. So the space is 1.45 meters, 2.5 meters in height, and 0.2 meters in thickness. So with this top face selected, what I'm going to do actually is I'm going to press Shift S on my keyboard, and then I'm going to move my 3D cursor to selected. So selection to cursor. No, cursor to selected. I want the cursor to go to where I'm selected. So it's going to land up here. The reason I'm doing that is that I want a starting point for the tiles of my vent, and then just create the array modifier and move it downwards. So that's the thinking behind this process. Okay, and the reason I move my 3D cursor there is now when I add a new mesh, which in this case is a plane, it's going to show up where the 3D cursor is, the origin. Okay, and let's change these dimensions really quickly. So we knew that there was a 0.2 meter thickness. So like that. This length was 1.45, which is in the x-axis. So 1.45 in the x-axis. Now z is obviously 0 because planes don't have any thickness. Okay, so I want this to, I'm going to rename this plane to wall vents. And I'm going to actually change the name of this to wall vented, just to make it a little bit different. And I misspelled this one. Okay, there we go. Let's put this back into here. Let's put it into this place for the walls. And I also forgot to rename my bottom. All right, a bunch of sidetracks at a time. It's always good that if you forget to do something, just, clean it up when you see it. Okay, so with that in place, what I'm going to do is let's rotate this to get it a little bit more slanted. So I want to spin it around the x-axis like this. Let's go for that 45 degrees. So now it's slanted. No, let's spin it the other way. 45, so it's pointing downwards. This is obviously too high inside of the mesh, so I got to shift it down a little bit. So let's just shift it down, and let's just go 0.1. 0.1 is a nice number. And that's going to put the vent right over there. All right, that's pretty nice. So because I have shaved 0.1 meters off the top, I'm going to keep in the back of my mind to shave 0.1 meters off the bottom, just for consistency. So in turn, what that would mean is this length was originally 2.45. And if I shave 0. Something off the top and then shave something off the bottom, it's going to change this number to 2.25. There we go. So what we're going to do is let's apply the array modifier now to this. Actually, let's apply the solidifier modifier first, just to get some thickness into place. So you can see that if I increase the thickness, this vent tile is going to be a little bit more thick. So we just kind of choose a number that looks good. 0.4 looks like a good thickness. So that's good. And then at this point, we can add the array modifier like this. All right. So for the array modifier for these vents, we can actually go under fixed length because we calculated an exact length that we want. So that length was actually shaved down to 2.25 like this. And I obviously need to put it in the correct factor. We're going downwards. So like this. Oops, this should be -1. And the reason I think this is not working is probably because I didn't apply my scale and rotation yet. So let's do that. Rotation and scale. There we go. So yes, this is why we always apply rotation and scale before using these modifiers. You're going to get funny business. So all the rotations are set like this. And all the tiles are pretty much put into place. And the length, I think, even if I put, 2.25, it just rounded it to 2.2. There we go. So we have a nice little bit of space on the top, nice little bit of space in the bottom. Everything's looking consistent, which is awesome. Now, of course, I want to apply it to the walls on the other side. So all I need to do is add that additional mirror modifier, use the rotation of 0, and I'm setting this into the y-axis. So you can even see that it gets placed right over there. There you go. The vents here are pretty much done. That is amazing. Okay, we want to put the vents now for the vertical edges. So let's do that. And I'm actually going to do a little bit of a similar process. So I'm going to tab into edit mode. And the first process, we're going to bring that cursor, so cursor to selected. And let's take down these dimensions. So we have 0.4 in length, 0.1 meters thick. So let's add, I want to add into my edges tab or collection. So mesh, let's add that plane. We're going to rename you to be edge vents like this. So we know that 0.4 thick, 0.1. So that gets nicely put into place. Rotate this 45 like this. And we need to shift it downward to start around here. So around that 0.05 mark. Yeah, 0.05 mark looks good. So I've shaved down 0.05 from the top. So if this is 0.4 meters tall, that means 0.4 minus 0.05 minus another 0.05 for the bottom. That's going to give me a 0.3 meter working area. So that's going to be helpful for my array modifier. Okay, now with that into place, let's apply that scale, rotation scale really quickly. Let's go back and add the solidify modifier. So this little space is smaller, so the thickness doesn't have to be as big. So in this case, I'm thinking a 0.02 thickness. Looks kind of similar to relative to how these wall vents look. So 0.02 meter thickness looks good. And then we're going to add the array modifier. We want to use a fixed length, 0.3, and we want this to go down in the negative x direction. There we go. And that's going to put 4 nice vents into place, which is pretty cool. Now, at this point in time, I'm thinking that these gaps on the top and the bottom are a little bit too wide. So I'm actually going to move this up slightly. Let's say 0.1. Oh, no. That's not what I wanted to do. It was 0.01. That's going to reduce the little space on the top. Let's see if I increase this length. Okay, so a new one is on the bottom here. It goes to the mesh. So what happens if I try to shave down the distance between the tiles? So let's move this downwards like this in the other way. Okay, so it's still at this length on the bottom. So let's go back here. There we go. Kind of just fiddling around with this. That 0.3 meter length and 0.07 offset looks a little bit better. It kind of fills up the area a little bit more. And from afar, it looks pretty good. So yeah, sometimes you might like to detrack and go off something that feels a little bit better. And we did exactly that here. So this is the result I like for these vents. And now we've got to put them into all of the other vents. So we got some mirror modifier action to do here. First thing is that very cleanly in the mirror modifier, we want this, let's put the rotation 0 mirror object. That's going to put this vent over here. Let's put these ones into place by adding this Y axis. And to put these ones into place, we're going to add that Z axis. Actually, no. For some reason, I looked at this space at the corner and thought it was a vent. Okay, no Z axis, since everything is on the top. Okay. There we go. Now we also want to fill in these ones on the side. So we're going to need that little rotational symmetry magic. So we're going to add another mirror modifier, set the object rotation to the 45 one. And in this case, in the x-axis, that's going to rotate that plane, and it's going to put all these 4, rotate them all into place just like this. So it's pretty amazing what you could do with the mirror modifier when you understand how rotational symmetry works. Now, all in all the vents are in place. It's looking absolutely amazing. And finally, we just have the screws left. So let's create a collection called screws. And actually, while I'm here, I'm just going to create one called vents. I think it's better if I just store the vents into their own little collection. So wall vents and edge vents. I'm going to put you in here. All right, screws now. So this is the way I'm going to do this. I'm going to hide all of these meshes because I just want to focus on the screw right now. And I'm going to Shift S, cursor to world origin. There we go. And here I'm going to model the size of my screw. So how am I going to make this screw? The screw can be created. We're going to use a cylindrical mesh like this. I don't know why I have this draw tool enabled and I lost my pop-up menu. Okay. Add cylindrical mesh, a cylinder. And I'm going to change the number of vertices down to 6 because a hexagon shape for a screw is a good shape. The height of this prism is 2 meters. So because I want the screw to lie on the face of the walls and the edges, one way I could do it is I want to change this origin and move it to the bottom. So a nice easy way to do that is go up half the height of this cube, which is Z is 1. So now this face lies on the bottom. I could set the origin to 3D cursor to place it here. And therefore now if I change the height, it's just going to go in one direction. That's great. And this allows me to change the height of this hexagon similar to how you do with the solidify modifier. And the reason I didn't use a solidify modifier with a plane is because I don't think a plane allows you to change the actual shape. So that's why I went down the cylinder route. So with this in mind, over here, what I want to do is that let's start with the walls here. So I'm going to bring the walls back into place. And I want to start configuring some of the dimensions just to get a feel for it. So what I'm actually going to do here is, let's go to this wall for instance. So this wall I could see is at a y of negative 2.75. So what we're going to do is I'm going to move this y to negative 2.75 like this, rotate it 90 degrees so that it's flat and the origin is on this side, not outside of it. And what this allows me to do is now over here, I can move this screw directly across the plane of this. Just like that. So this screw is very, very big. So there's a couple things I want to do to it. First thing I want to do is the top of the screw is a vertex, like this. I would prefer if it was a straight line, so I need to rotate it somehow. So an easy way of how to rotate the hexagon in this case is actually you just spin it by 30 degrees. And that's going to put the flat face on top. Now, the reason I knew it was 30 degrees is because there are 6 edges and 6 vertices, and they're all kind of pointing in their own faces. So if you're spinning an object, remember you could rotate an object 360 degrees like this. And because there's 12 of them in total, that will tell you that one rotation to shift the next edge or vertex on top is this calculation, which is 30 degrees. So math always comes back to help me a little bit in how to spin things accordingly. Okay, so either way, it's 30 degrees. So with that in case, what I could do now is I could scale my object down to get appropriate size of what I'm looking for. And I think that a size of a screw around this shape seems to be okay. So I'm actually going to select the wall and the screw, go into edit mode, because I want to see some of the locations of everything. So I want this screw to be the same amount of distance, like it's going to be in the corner here. So I want to actually put it somewhere around here, and I want these distances to be the same. So one way I could achieve this is I could take note of this coordinate over here, and then just move it a consistent amount of distance in the X and Z direction. So this coordinate over here is at negative 1.925. So let's we gotta go back in object mode for this. So negative 1.925 like this, and the other coordinate was at 1.425. So 1.425, that's gonna bring it here. So in object mode like this is a little bit too big. So let's shrink it down over here. And I just want to move it somewhere, something like this looks fine. And again, I just want to move it consistently in the same X and Y direction to get this into place. So if I rotate this a little bit, maybe I get a side profile. Let's just move this a consistent amount of distance. So let's see. If I go down, let's say negative 0.2, and then the X direction 0.2, and put it somewhere here, how's that going to look? Not bad, not bad. I think I could do a little bit better. Let's go 0.3. Oop. 0.3, 0.3. And you know what? That one looks a little bit better. Okay, and let's change the height of this to match. So what I'm going to do is let's apply that rotation and scale, and now I want to change the height for something appropriate. So let's go 0.1. Okay, let's go half that. Okay, let's make it a little bit smaller. 0.01. Nope, 0.025. Okay, 0.025 looks like a good thickness. There we go. So I'm happy with a 0.025 thickness for my screws. So, put all the screws in place like this. I could start putting all of them into place pretty easily by using the mirror modifier tricks. So let's go ahead and go mirror modifier. And we're going to start by using the rotation 0, 1. So that's going to put this into place to get these bottom ones, Z-axis, and then to get the stuff on the other wall, that's going to put that screw into place. And of course, we want to rotate that as well. So a new mirror modifier, rotation 45, and one of the axes. So now all of these screws are in place just like this. Okay, this is a good starting point. And of course, if you ever want to change the size of these screws, you have a modular way of doing this. There we go. That is looking pretty good. All right, now I want to do the same thing for the, I'm going to rename this wall screws like this, put that into place, and I'll go ahead and just apply the scale one time. All right, now we need what the edges are going to look like. So let's add in those vertical edges back like this. And what I want to do in this case is I want to put the screw right here in the middle. So for these screws, I want these screws to be right here in the middle, which is exactly where the origin is. So I am going to take this screw, duplicate it. I'm going to rename this edge screws, or maybe vertical edge screws to make it a little bit more specific. Let's take away these mirrors for now. The biggest thing is to get it right over here. So I've just moved it randomly. You can see I've just hidden. Let's take a note of this face. So this face is on Y of negative 2.85. So Y is equal to negative 2.85. So let's do that. Vertical edge screws. So Y is negative 2.85. That puts it there. And I want it to be right here in the middle. So the height of it is this. And what about the X dimension? The X dimension should be the same. So 2.5. There it is. So it's nice and centered in the middle. It has 0 height. That's going to put it right in the middle. So notice that middle that I used for the height was actually the height of the entire vertical edge, not just halfway down this middle face. Okay, so now with that screw into place, let's just put them all. So mirror object, we want to use rotation of 0. We're going to put X and Y. That's going to give us this side and this side. And then we're going to add a new mirror modifier with rot 45 and put in the X axis. That's going to put all these middle edges, middle screws into place. And now at this point in time, I could just make everything visible again, like this. And this is what our crate has become. So we've done a lot of work in this episode, or this lesson. Honestly, all of that is kind of worth it. So just take a step back, look, and admire all of the hard work that we were able to achieve in this video. It's something that looks incredible, and it's something you should be super, super proud of. And sure, we did spend the first few chapters covering a lot of interface and theory, but hopefully you can see the importance of why we did that first. It's because now we can retain that information and actually put into practice, and now you have all these tools and understanding in your arsenal. So the next time when you hop into Blender and you start to model your own prop, you can start to achieve a finished result or a lot of work in just one sitting. So great stuff, everybody. So, at the end of all this, you've learned how to use Blender's most essential modifiers, not just individually, but powerful combinations of them too. So by now, I hope you start to feel a little bit more confident, more efficient, and have more control of all of your models. So with all this heavily modeling done, in the next lesson, we're going to talk a little bit about cleanup, where we're going to think about ways where we can further optimize our model by reducing these statistics that we currently have here, whilst retaining the overall shape. So otherwise, be proud of yourself, have fun, and I can't wait to see you in the next lesson.